Children, the last video class I have taught the concept of acids and bases, the theory given by many scientists. For example, Arrhenius, Lowry Bronsted, Lewis concept, everything I have taught. Today we are going to learn about strength of acids and bases. The strength of acids and bases can be determined by the concentration of H3O plus or OH minus produced per mole of the substance when dissolved in water. Generally, we can classify the acids and bases as strong acid or weak acid, base as strong base or weak base. So, what is a strong acid means? It should be completely dissociated in water. That is the strong acid. But weak acid partially dissociated in water. When strong acid when completely dissociated into water, there is equal amount of the undissociated and dissociated. But in weak acid only partial dissociation, so there is no equilibrium between the both. So to define the strength of the acid, let us consider the following example. HA acid, consider as HA, when dissolved in water, this acid gives H plus to this water, so it acts as an acid, proton donor, this is proton acceptor, base. So forming H3O plus A minus. Then while following the reverse reaction, this H3O plus donates a proton. So this acts as a proton donor acid to this accepts. So it acts as a base. Now the equilibrium constant for the above ionization process is given as product H3O plus concentration, A minus concentration by HA concentration, H2O concentration. Here we can omit the concentration of water because its concentration is more, large excess. So it can be omitted. So ionization constant of acid Ka is equal to H3O plus concentration, A minus concentration by HA concentration. Ka is called as ionization constant of the acid or dissociation constant of the acid. It measures the strength of the acid. Acids such as HCl, HNO3 are completely ionized. So they are also having high Ka value. But acids such as, so they act as strong acids. Acids such as formic acid, HCOOH formic acid, acetic acid, CH3COOH. These are partially ionized in solution. So partial ionization means an equilibrium exists between the unionized and the dissociated. So the acids with Ka value greater than 10, they are considered strong acids. If they are having the value less than 1, they are considered as weak acids. So as per the example what we have learned, HCl, for example, acid you can take as HCl plus water giving H3O plus Cl minus. Proton donor, proton acceptor. So acid base, here proton donor, proton acceptor, acid and base. So due to the complete dissociation. Acid HCl is a strong acid, complete dissociation. So equilibrium almost 100% lies to the right only. So based upon this, the strong acid, weak acid, very weak acid, very weak base, strong base, everything given in tabular column in book page number 6. Based upon this concept is given in book page number 6. Strong acids, weak acids, very weak acids, strong base, weak base, very weak base. Everything can go through strength of acids. What I have taught you can follow. Next, ionization of water. Already we have learned an acid is a substance which can donate a proton, base is a substance which can accept a proton. Here pure water itself has a little tendency. For example, take two water molecules, H2O plus H2O. Take two water molecules. Here this H2O donates a proton to this one. So this acts as an acid 1. This is base 2. Now this is accepting a proton forming H3O plus OH minus. Then this one donates a proton to this one, proton donor, proton acceptor. So acid 2, base 1. So these two are conjugate acid base pairs and these two are conjugate acid base pairs. In the above ionization, one water molecule acts as a acid while the other acts as a base. So the dissociation constant K is equal to H3O plus concentration, OH minus concentration, this one product by H2O. So H2O power 2. Here already we know the concentration of pure liquid water since it is very much greater, its value considered to be 1. So Kw, ionic product of water, H3O plus concentration, OH minus concentration. Kw represents ionic product of water. It was experimentally found that concentration of H3O plus in pure water, the value is 1 into 10 power minus 7 at 25 degrees Celsius. Since the dissociation of water produce equal amount of H3O plus and OH minus, since the value of H3O plus value 1 into 10 power minus 7, OH minus value will also be equal to 1 into 10 power minus 7 at 25 degrees Celsius. So based upon this fact, ionic product of water at 25 degrees Celsius, Kw is equal to H3O plus concentration into OH minus concentration. The value of this one is 1 into 10 power minus 7 at 25 degrees Celsius. The value for this also 1 into 10 power minus 7. So multiplying the both we are getting 1 into 10 power minus 14. So like all equilibrium constants, Kw is also a constant at a particular temperature.